We have 40 minutes to talk about Apache Metron and Apache Spot, two big data tools for cybersecurity. My name is Alex Rodney. I am from Fairleigh Dickinson University, and this work is actually done under NSA grant. Here is the number of the grant on the slide. It's conducted at FDU. General title of this work is Cybersecurity Workforce Education CNAP Initiatives. That's a National Cybersecurity Action Plan. And the full title of this comprehensive work, which consists of 3 projects, is developing hands-on exercises for secure embedded system design and security data analytics for computing and engineering students. Basically, the goal is to create a set of laboratory assignments and even design a new class which can be used to promote cybersecurity education. Primary investigator, the main one, is Dr. Kalyan Mandal, and then my colleagues, Dr. Rai Rao is responsible for secure embedded systems part. Dr. Phillips is responsible for advanced systems programming, and I'm in charge of big data analytics and cybersecurity. That's what we are talking about now, and I think personally this is the most exciting part, of course. And I'm not alone in this endeavor. I had help from graduate assistant Pooja, who used to work with us in fall 2017, and another assistant, Suhag, is actively participating now in this spring 2018 semester. Suhag is, and Pooja just graduated Fairleigh Dickinson, and that's why she stopped working. All right, this is the project, the goal and the status of the sections which we had to achieve, and I can say we have good progress. I want to walk you through this, and probably what I didn't mention, that this presentation consists of 3 parts. Part 1 is about the project overall. Part 2 is about Apache Metron, and Part 3 is about Apache Spot. So then you will have some understanding of how it works and what it does, and I'll show you some illustrations too of what is going on in there. All right, so we had the 7 goals in the proposal which we submitted to NSA. First one was to integrate Apache Metron. Second, to integrate Apache Spot. And you would say, what do you mean by integrating? All right, we had, since fall 2005, we had a cluster, a Hadoop cluster at Fairleigh Dickinson University. I'm just going ahead to a few slides ahead, and then I will skip back to show you where we are. So that's how it started. We set up an Apache Hadoop cluster at Fairleigh Dickinson. It was in fall 2015, and there was a new class introduced, big data analytics with Hadoop and R. All right, so I myself had to make a setup, perform maintenance, do tune-ups, do user management, listen to student complaints, improve the class, and do other things to make it better. Myself, what I didn't actually expect, I had to acquire some skills necessary for the current project, and actually now it helps unexpectedly in some moments. And of course, it helped the cluster itself, and the big data technology helped to teach students new technologies related to big data analytics, to big data processing with Hadoop and its ecosystem. All right, students got jobs. Some students got better jobs. Some students got something regular, but still, I listen and I hear that students get jobs related to Apache Hadoop. All right, so what was in there? Original Apache Hadoop cluster was a hardware cluster, 2 IBM nodes, 2 more powerful nodes, which we received as a part of IBM grant. Then it was 3 HP nodes acquired elsewhere, less powerful in that configuration. And originally we had a lot of problems because it was not enough operating memory, RAM. Just recently, last year, we had a new cluster introduced. That's a 5-node cluster of virtual machines based on VMware tool, and it has more memory, it's more stable, and actually I can tell you it's more convenient to maintain it, because when it's a hardware cluster, you have to physically be present on in the server room and put yourself a disk with installation, and with VMware you can do everything remotely: wipe, erase, restart, whatever you want. Okay, how did we use it? We used this for big data, a class for hands-on assignments, for basically for labs, but it was used as homework assignments. What we studied and what we learned there, what we taught, it was MapReduce paradigm, HDFS, that's Hadoop distributed file system, Apache Ambari, that's a tool for provisioning, for maintenance, and for also user interface for some of the tools. It has Hive view, Pig view, and some other views which provide convenient user interface, and students actually loved it. That at first they had a slow immersion. They had to work with Apache Hadoop first through user-friendly interface, and then we moved to command line interface. Okay, other tools: HBase, that's a NoSQL, a near real-time database. Apache Spark probably is the #1 tool now for distributed processing, because it does in-memory processing, and other tools. It was a number of tools. Okay, other possibilities for us, for FDU and for other academic institutions, would be to use Cloudera Academic Partnership, which is absolutely free, and many schools use it. I wasn't able to use it because I couldn't convince our lawyer to sign the petition, just to sign an agreement that we will not be modifying the software. But I'm not a legal person. I probably just can't convince other legal person that it's a good thing. Hortonworks has also academic program. Currently, they are revamping it, redesigning it, and it should become available soon, I hope. Okay, but let's get back to the goals. I just explained you what did I mean by integrating Apache Metron and Apache Spot, meaning that we just wanted to add 2 new big data tools to Apache Hadoop ecosystem. And the main point, important point here to understand, is that both Metron and Spot, they require tools from Apache Hadoop stack of applications. For example, they need Kafka, both of them. Apache Metron relies on Elasticsearch, which actually is not shipped via the Hadoop, but it can be working with it. All right. Apache Metron relies heavily on Storm and its topologies too. Okay. So as you see, Apache Metron integration has been done. Apache Spot is pending. We actually installed it on a cluster, in the cluster on one of the nodes there, and tested it. The thing is that Apache Metron is already full-blown application. It's top-level Apache application. Apache Spot, on the other hand, is still in Apache Incubator. So what happened, Apache Metron had a strong and big enough, proficient enough team of developers, all the respect for doing such a complex application to them, who were able to graduate this application about a year ago. I think almost on this date. It was actually April 17th of 2017 when they graduated it, and now Apache Metron is a top-level application. Apache Spot is still under development in the Apache Incubator. Then, so this topics first is done, second expansion almost done. We added more nodes to the cluster, created a new cluster based on VMware, which is actually more convenient to use, which is better. Then load cybersecurity data sets into a big data warehouse, which is Apache Hive, and also Apache Hive should be used with Apache Metron as a part of a data vault. All right, and we will talk a secure data vault. We will talk about it a little bit later. And graduate assistant Pooja helped with completing this phase of the project. Then design lab assignments, use lab assignments in the cybersecurity course, set up a cluster in a public cloud, and for a public cloud we used Amazon Web Services. The initial plan was to use those use cases prepared by Apache Metron developers mostly, and a few also, and the demo available from Apache Spot to design these labs. Then use these labs in assignments in cybersecurity course when they are designed, which should be done actually this week or next week, and set up a cluster in public cloud. These three topics sound straightforward, and you might ask, what's the challenge? Because this is an academic project, you got a grant, right? And it should be something complex, but it sounds really simple. In fact, following use cases, installing Apache Metron did not work for us out of the box at all. We went through different configuration. We tried installing Apache Metron on Ubuntu 14, Ubuntu 16, CentOS 6, CentOS 7, on a standalone hardware node using Vagrant, Ansible, using Docker, using VMware, using virtual machines, and initially nothing worked. I do not, of course, do not blame the developers, and documentation is good and thorough. The problem is that what we figured out, we did not have exact configuration. This is the open source system. It requires certain dependencies, and commonly what we experienced, dependencies either didn't match, versions were different, or dependencies were missing, and it was not clear which was missing. So it took a lot of time actually to install it and to make it work. And we understand this is open source project, and of course we do not complain. All right. This being said, setting up in a public cloud, you might think, why do we want just say public cloud? Why can't we just set it up as a virtual machine on a student desktop? In the end, you just want to create lab assignments for students. And I can tell you that we already went that way in fall 2015, and that was the original idea too, before even setting up a cluster, to make students test Hadoop and do assignments on their laptops or desktops in virtual machines. And it didn't work either. Why? The reason is that many students used Windows 10, and new hardware comes with a new UEFI, right, new CMOS, and their virtualization is disabled, or it's enabled, but as you can see it in settings, but in fact it's disabled. So then you need to go back and forth, enable, save, reboot, enable, save, reboot. And you can imagine a line of 70 students to my office, unhappy students saying that, Professor, something doesn't work. That's not a good situation. So that's why we decided actually to move it out to the cloud. Okay, and in the cloud then there was another problem, right? And I'm already concluding the part one about the project. There was another problem because the configuration listed for Apache Metron requires a cluster of 5-6 very powerful nodes with up to 60 gigs of RAM memory and 2 terabytes of hard drive space, and I think 8 core CPUs there. And can you imagine how you could maintain it? Another problem, which was unexpected, unanticipated from before, in the big data class, we were able to use the same cluster for 70 students at a time per semester, right? It was heavy use of RAM, but it was sometimes it was unstable, but with the move to VMware, it normalized. The problem with Apache Metron and Spot is that students need to use it as administrators at some point, and then if a student 1, say, does work on lab 1, the student, it's the same cluster, cannot be used at the same time by other participants. You see, so it was decided that it's say financially infeasible to maintain, say, 70 clusters by an institution of 6 nodes, 6 very powerful nodes, and it comes with a price from Amazon Web Services or other cloud solution. So what we did, we moved, which is actually not recommended by developers, but we moved all the applications and set up a single node cluster on a powerful machine, on a powerful EC2 instance in AWS, and I'm now talking about cluster set up in public cloud. With about 60 gigs of RAM, about 16 CPU cores, and 1 terabyte of SSD solid-state drive. And actually, after again some troubleshooting, it started working, and we were able to test assignments. Okay, so design and evaluation is in progress, and it is moving well. Prepare documentation. I expect to do this in the very end of the project. Dissemination means talking to other people, sharing the results, and this is what I'm doing. I hope you will be getting something useful. Okay, since this presentation targets different people of different backgrounds, right? Let me tell you a little bit about Apache Hadoop. What is Apache Hadoop? This is one of the most popular, I would say personally most popular, but some people may disagree, open source big data ecosystem. Why would you say ecosystem? Because if you look at Apache page of Hadoop, it says that Hadoop is just a library. Actually, it's a collective term. It's first, it's a set of applications for distributed processing of large data sets using MapReduce paradigm and other ideas and too. It's scalable. Cluster can run on a single node up to 1,000 nodes, thousands, right? Hadoop version 1 had a limitation allowing up to 4,000 nodes. Hadoop recent versions 2 and up doesn't have this limit anymore. Hadoop supports data redundancy by design. When data is ingested into HDFS, and HDFS is Hadoop Distributed File System, there is a parameter which makes 2 more replicas of the original piece, right? So big data set is cut into pieces called splits, and each split is stored 3 times on different nodes in the cluster. It is possible to make the cluster work on a physical set of machines, in virtual environments such as VMware, right? Or in the cloud, for example, Amazon Web Services or Microsoft Azure. Okay. Of course, Azure and AWS come with a price, but anybody, not only students, can get a free trial and see how it works for them and then commit. Another good thing about cloud deployment is that you don't need to decide how many nodes you need, because you can adjust it anytime. It's flexible. Many startups and smaller to medium companies prefer keeping their clouds in the cloud, keeping their clusters, Hadoop clusters in the cloud. Okay. Another thing is what you need to know. Apache Hadoop has its own website at Apache, right? Portal. But Hadoop is distributed from several vendors. Most known are Hortonworks and Cloudera. I think these are the 2 biggest competitors. You would say, this is open source, this is free software. How do they make money? Still, you get distributions for free, but then a setup comes with a cost, or maintenance comes with a cost, right? If you experience some problems, you need to subscribe to a certain plan and pay for it. That's what companies do. What are applications included into Apache Hadoop distributions? Those are mainly HDFS, right? Hadoop Distributed File System. That's a service. Then Yarn, that's a scheduler, yet another resource negotiator. Ambari, which allows and provides with the automated maintenance, provisioning, monitoring, and user interface. Hive is a big data warehouse. Spark is for in-memory, fast in-memory processing. Storm was designed in Twitter, and it allows streaming data, right? HBase is an NoSQL database, real-time. Kafka is used frequently, creates data flows, which data feeds into Apache Metron. Uzi is for data migration, for ETL, right? Many people know about ETL, and it's very popular. Extract, transform, load when you need to get data from other platforms. And of course, Metron and Spot come to play. And this is what we will be talking about. This is how we used Hadoop at FDU. I will just skip this slide. Welcome, part 2. Finally, we start talking about Apache Metron. And this will cover the largest part of the remaining presentation. Metron evolved from Cisco OpenSOC system, right? That's Open Security Operations Center. That's a big data security analytics framework for consumption and monitoring network traffic and machine exhaust data. What's machine exhaust? Those are log files, for example, of a data center. Cisco OpenSOC, Open Security Operations Center, was designed or envisioned to work on Hadoop platform, which we just discussed, and OpenSOC uses Kafka, uses Storm, and Elasticsearch. Elasticsearch is an open source indexing and search engine. What could OpenSOC, Security Operations Center, do? It could process unstructured data and streaming data, ingest this data, right? Provided capability for interactive querying, real-time search, scalable computation, real-time alerts, anomaly detection, data correlation. Also, OpenSOC provided with rules and reports, predictive modeling via user interface and applications. Actually, what I can tell you, that Apache Metron supports all these features, but they evolved. They also, Apache Metron can do more things, basically. But this is the core, which, as I understand, migrated into Apache Metron. And we will actually see here, this is the evolution of this tool. In September of 2013, there was the first prototype of Cisco OpenSOC, Open Security Operations Center. In December of the same year, Hortonworks, that's the corporation, right, which is a vendor of Apache Hadoop, joins the project. During these 2 years, up to April 2015, the platform development is complete for OpenSOC. First beta test was conducted at the customer site. And you might think that I am very familiar with it. No, I was not a developer. No, I am not involved. I got all the information from the web, and this is legitimate. This is what academicians do, right? Okay, next phase, June 2015. OpenSOC became a community edition, and I can tell you that this is common with the Apache Hadoop ecosystem. Many tools were designed by big corporations who have a large number of skilled developers, such as Facebook, right, such as Twitter, such as Yahoo. And they then donated, or let's say transferred their solutions to the community, Apache community, and now those tools are available under the Apache license. Moving on, July 2015, Cisco decided to stop support OpenSOC, right? And then later the same year, James Sirota, Cisco chief data scientist and lead of OpenSOC, joined Hortonworks, and it looks like one of the main people actually made a decision. Then in December 2015, Metron accepted into Apache Incubator, and you see this is where incubation phase begin. A team working hard. I actually subscribed to two email lists and was informed up to some point of what was going on. The first release of Metron was 0.1, and it happened in April 2016. Happy moment, April 2017, that's when Metron graduated Apache Incubator. And here we are now, 2018, Metron's latest version is 0.4.3. Actually, Metron's website says that the latest version is 0.4.2, but if you clone a GitHub repository, you will be able to compile version 0.4.3. Moving on. Finally, Apache Metron. What's this? This is a cybersecurity application framework which allows to ingest, process, and store diverse security data feeds at scale. At scale means like at a big speed, in big amounts. And it works on top of Apache Hadoop cluster. Apache Metron is capable of detecting cyber anomalies and enable a rapid response. And nowadays, with all the different attacks, this is a very important features. Key features of Apache Metron. First, it has a security data lake, data vault, where it keeps all the already enriched, all the processed telemetry data. It has pluggable framework, which means it already has a set of hardware, say software sensors, software emulation of hardware sensors. It's possible to plug in hardware sensors and then stream data into Apache Metron. What are the sensors? Those are PCAP, NetFlow Bro. You can see this on the screen. Security application is the CM, right? CM is Security Information and Events Management. And also Apache Metron has threat intelligence platform for anomaly detection and applying machine learning, which could process real-time data based on past information. Okay, basically this slide tells us about 4 functional themes of Metron: platform, data collection, data processing, and user interface, allowing different types of analysts to work with it. Here is another look. Metron is a centralized tool for security monitoring and analysis. Integrates Kafka, Storm, Kibana, Elasticsearch. Kafka and Storm are used for streaming the data from different sources into Apache Metron for enrichment and storage. Kibana and Elasticsearch are used. Elasticsearch is used for indexing. Kibana is used as a dashboard tool. Okay. Metron can aggregate logs, index full packet capture, store enriched data, and produce advanced analytics, and apply threat intelligence to security telemetry. Okay, so here is some details which I have to skip because I'm running out of time. Unfortunately, that's Metron can do capture, store, can do real-time processing and application of enrichments. It has efficient information storage since it's running on top of HDFS, Hadoop Distributed File System, and it has a very nice looking user interface. You see, architecture of Metron consists of parsers, and parsing data comes from Kafka, right? That's Kafka is included into Hortonworks shipment of Hadoop. Enrichment is done by tagging message as an alert, for example, and assigning a risk triage level. And this is what our students will be doing after we are shrink wrapping these lab assignments. Indexing is done either with Elasticsearch or Solr and stored in HDFS, Hadoop Distributed File System. Then there is a Stellar language, right, for custom data transformation, and this is a custom language which exists only in Apache Metron. There is a model as a service where you can build or say train a machine learning model and deploy it into Apache Hadoop cluster, and then it will assign risk levels, for example, to incoming events. Data management, it's possible to store data into HBase for further use. The idea was also to store data in Hive. There is a profiler which works as a feature extractor, generating behavior of an entity, right? What's the entity? A server, user, subnet, or application. It's several ways to deploy Apache Metron. Vagrant-based installation, Amazon Web Services, manually on CentOS, with Ambari, Ansible Docker, RPM Docker, RPM packaging, deb packaging, then VirtualBox, which might or might not work, depends on a person's skills, of course, as everything else, and a single virtual machine as well. You see, what we actually preferred and what we used at FDU, we used here in the top right corner, you can see two icons. That's Hortonworks Data Platform and Hortonworks Cybersecurity Platform, which works together. Basically, Hortonworks Data Platform is the distribution of Apache Hadoop by Hortonworks, and HCP is basically, as we were able to identify it, is Ambari Management Pack, which contains shipping of Metron, Kibana, and Elasticsearch. Right? We could say, what about Kafka and Storm? Kafka and Storm are included into HDP or Hortonworks Data Platform. Okay. Here is a logical architecture of Metron. Here is data ingestion of telemetry data, either using NiFi from files, right, or using actual network tap, which could be installed somewhere into a network. And then this goes through event buffer, processing, enrichment, labeling, and storage for then analysis in Metron tools. And here we have it step by step. You see, this is step A, fast ingest from network tap of different types of data. Then here is an example of how this data looks like, and this shows you the main format or the main data structure, which is JSON, right? Here you can see different fields of a probe. Step B, that's basically another way of getting, if you do not have physical network taps or network sensors, right, it is possible to get data at rest, get data from files, from syslog, from REST HTTP custom API, and it's possible to use a NiFi, for example, syslog processor. Here is an example of how a raw captured event looks like. Okay, and we are moving forward. That's step 1, how raw events from telemetry security data sources are captured NiFi, then pushed into own Kafka topic, and then Kafka passes it to Apache Storm, right? And Apache Storm does parsing, normalization, validating, and tagging. Okay, I'm out of time, so I'm moving forward. Here is an example of tagging, right? The ingested data is then assigned, converted, say, to JSON format where the field timestamp, protocol, source address, source port, destination address, destination port, and actual original string is also included. Okay, at step 3, enrichment is done, and example of what enrichment means actually and does is that, for example, by IP address is queried against GeoIP data, and latitude, longitude coordinates, and maybe city, state, and country are embedded into that JSON which you just saw, right? Or it's possible to say that certain IP corresponds to host X, which is a part of a web server for certain e-commerce farm. And here is an example of this enrichment information. You see, this is latitude, longitude of destination IP, then the same data is available for source IP, also country and city and even zip code of a destination IP and source IP as well. Moving on, at step 4, labeling is done, and you can see an example of a labeling. If something hits in a rule, right, something becomes an alert, then there is a message or line in this JSON saying that that's alert produced by sticks, IPv4 address is, and some other information may go in there too. Then how do this alert persist? Then indexing is done either by Elasticsearch or Solr, and then the data is preserved in HDFS as a enterprise data vault. At step 6, you see this is basically all the data which we are able to acquire and identify is then going for storage in HDFS, and then it will be used by Metron for analysis. All right, that's here we have that can be done, what kind of analysis, real-time search, data modeling, integration and extensibility layers, adding new sources of data, adding new rules, adding new services, adding new enrichment. Here is how a Metron user interface looks like. These are the examples where you can actually pin certain alerts so that they come up first and produce information for people. You can create queries and query the data, and here you can see you can check certain boxes. Here you see, is alert true? Check it so that only alerts appear in the dashboard. Then here is example 2, showing how PCAP data is displayed with source port, destination, IP, and protocol. All right, and filtering is also allowed there. In example 3, it shows a chart timeline of broad data, YAF data coming from the YAF tabs. Here are the alerts coming from Snort. That's another. Here is a dashboard panels, which can be done in Apache Kibana, which is a dashboarding tool. I'll just have to skip through this. You see that's panel 3, 4, 5, and different roles of users who might be interested in using Apache Metron: analyst, investigator, manager, forensic investigator, security engineer, security data scientist. And here are 2 screenshots of Kibana interface. You see that's for Squid index, and here is a bar chart for the ingested data into Kibana, and here is a Metron dashboard within Kibana. And I just have 1 minute to show you Apache Spot. Unfortunately, Apache Spot also is envisioned as very similar application with the telemetry, parallel ingestion framework, machine learning, operational analytics. That's also open source software, but it comes from a different vendor. It comes from Cloudera, and that's a different Hortonworks distributor. It also has a user interface. You can actually get a demo of Docker by downloading it from Apache Spot website and run it on a test data and see how it looks like. It has 4 modules for ingestion, machine learning, operation analytics, and setup. This is a brief view of ingestion, that it accepts flow of DNS and proxy. Then it goes also, as in Metron, through Kafka topics. Then there are different flows. Unlike Metron, it uses, instead of Storm, it uses Spark streaming, then stores in Apache Hive, right, and then HDFS. And here are also a few slides showing Apache interface. This is a network view. This is interface showing filtering and scoring. This is alerts, basically, but alerts are called suspicious packets here in Apache Spot. Some information you can see is available as a pop-up messaging for quick analysis. This is a network view also with certain pop-up messaging, and the end is references where you can get this and more information from. All right, and the slides, the presentation is over, and I think I'm also out of time. Sheldon?
Yes, sir. How much material do you have left? And maybe you can clear that up.
I think we scheduled from 110 to 150, but if I went too fast, and if you have time, maybe is it possible to allow audience to ask certain questions?
Yes, absolutely. So for the audience, if you have any questions, please feel free to include it now.
I was watching the question box during the presentation, and I didn't really. I see people from Fairleigh Dickinson and from Tech Community College in North Carolina, but I don't see much there.
Okay, it appears we have one coming now.
Do we have access to the recorded session? And I think this looks like the last name of our graduate assistant.
Yes, actually, today's recording and access to past CAE technical recordings can be found at the following address. I'll put that in chat for you guys.
Thank you, Sheldon.
Okay, if anybody else has any questions, please feel free to include that in chat.
All right, and anyway, if this was too fast, maybe for some people, we will be presenting on this topic more. We will be publishing, and finally, when the project is over, which should happen in August, September, then we will distribute this. We plan to distribute this for free, of course, as virtual machine images for Amazon Web Services, for VMware, and maybe as disk images for to install on the hardware cluster. So that's and we will also provide documentation for lab assignments as well.
Okay, we had a
Okay,
regarding data format.
Data format can change upstream and downstream. It can break things in Elasticsearch. That's a good question, and frankly speaking, many things can break Elasticsearch and the rest because first we are not say the developers, and this is still open source, and you have to be accurate since you are working as an administrator. Okay, how far should we serialize data upstream? All right, so an example of use cases we went through, for example, what we need to do, we need to say pull Zookeeper. Zookeeper is another tool of Apache Hadoop cluster. We pull Zookeeper configuration, we create Kafka topic. Then this is passed to by Apache Storm streaming into Elasticsearch, and it ingests this into an index, and this data already comes in JSON format, which is being enriched, right, and which is being monitored for certain, for example, rules. If this is an alert, if it triggers an alert or doesn't trigger an alert, and this is already done by Metron also. It looks into this data flow, and if an alert is triggered, then it appears in Metron user interface. Then also it goes, say, Apache Kibana, which is a dashboard tool. It connects, if I still can get access here, Apache Kibana can connect to the data and visualize it in a user-friendly way. Yeah, here you see dashboards in Apache Kibana, right? Different dashboards. Some dashboard was available in the previous version of Metron. Currently in 0.4.3, I haven't seen it yet. It is possible to build your own dashboards as you wish using Kibana, and there are also, if these slides, as I understand, should also be available in references in the very end. There's a link of how to work with the Kibana interface, which was designed by Hortonworks community. So that's and how far should we serialize? I hope I answered your question. So there are several things involved when we come with raw data. When we start with raw data, that's Zookeeper configuration, right, which is basically a manager of Apache Hadoop ecosystem. We can think about it this way. Then there is Kafka, there is Storm. Then data goes into Elasticsearch, data goes into Metron, data goes into Kibana. All right, I see I see both graduate assistants talking. Okay, is the Metron Edge engine? The question is the Metron engine based on Spark for real-time processing? Can it apply Spark SQL for machine learning? Is Python supported for customization? And that's the first question. And second question, if any raw data that fails in that schema is filtered in Kafka topic. All right, it's possible to actually view even in Elasticsearch interface which documents failed, and it's possible to see to monitor say Apache Storm and the Apache Storm user interface for Metron shows also what happens with those data streams, data feeds, right? How many workers are assigned, what happens to data there. It gives you an idea, and you can click and see more details in it. Um, of course, you see if some data fails, probably if data is in wrong format, you see it depends on how the application is designed. It's if it cannot be fed, say, with supplied sensors, then you can modify a supplied sensor by yourself. So you configure it and write a custom one. That's one. Or you can also use a programming language such as Python to, say, streamline this. And going to question one from Gurav, can it apply Spark SQL for machine learning? From what I know, you can apply Spark and with Apache Spot, not with Metron. So I haven't seen applications of Apache Spark with Metron, but Spark streaming is used, you see, in Apache Spot, but Apache Metron uses Kafka and Storm for streaming. And then Spark SQL should be available, since it comes with Spark streaming. I think it's probably, I would say probably possible to plug it to Apache Spot. If you want to query data in Apache Metron, that's where you need to use the Stellar language. That's query language. That's language for querying, for data transformation, and other things done in Apache Metron. All right. And one more question here: is Python supported for customization of Metron? Yes, some examples are actually there that you can use a Metron from Python, and it also comes with some Python scripts as well. And Apache Spot also uses Python too. So that's Python is getting increasingly popular in data science, and recently, just last year, it became a more popular language for data science even than R. And the overall, Python is a, say, general language in which you can do almost anything, though in R you can do mostly data processing. All right, are there any other questions? I see a person from South Carolina, and but I do not see. I don't think, Sheldon. I don't think we have any other questions.
Okay, and Doctor, I'd really like to thank you for today's presentation to the community, and I'd like to thank everyone here for showing up. We had a great turnout, and had a high peak in viewers. And if you aren't already a part of the email list for all CAE talks and forums, be sure to send an email to caetechtalk@nsa.gov so you can be a part of that. I'd like to thank everybody for